Okay, so we are now at exercise number 16, and let's review what we have had so far. So we have two progressions, a geometric and an arithmetic progression. We know some relationships between certain terms, and using these relationships we managed to write two equations with two unknowns, q and d. Q is the quotient in the geometric progression, and d is the difference in the arithmetic progression. Alright, and using these two equations we managed to reach to this second order equation, which only contains q. This is a normal secondary equation. We can use the solution that you can see here. So what we can write is q12 is minus b, which is, this is minus b, this is b, so minus 5 is b, so minus b is 5, plus minus square root b square is 25, minus 4 times a is 1, because there is a 1 here, times 4, because c is 4, over 2 times 1, okay, is equal to 5 plus minus square root 25 minus 16 over 2. 16 minus 25 minus 16 is 9. The square root of 9 is 3, so plus minus 3 minus 2, which gives us the following results. q1 is equal to 5 plus 3 over 2 is 8 over 2 is 4, and q2 is equal to 5 minus 3 over 2. 2 over 2 is 1. Okay, let's check first. So we have two equations, two solutions which we need to deal separately with. Okay, so the first one, if q is equal to 1. What does this mean? Then it means that basically how can we write the geometric progression? The a progression looks like this. The first term is 5, right? And the second term is the previous term times q, which is 1, so it's still 5, and then it's still 5, and it's still 5, etc, etc, etc. So it will be the constant 5 series, and then the b series will be also the same actually, but you can check using this equation, because 5 times 1 is equal 5 equal to 5 plus 3d. It means 3d is equal to 0. So 3d is equal to 0. It means d is equal to 0. It means that in the arithmetic progression there is no difference between the members, between the terms. So 5, 5, 5, 5, etc, etc, etc. So if this is the solution, then what is the answer to those questions? Well, how can we calculate the fifth term of the arithmetic progression? This is the formula we will have to use. So the fifth term of the arithmetic progression is b5 is equal to 5, right? Because yeah, it's simple, everything is 5. So, and then the first 5, let's see here, the first 5 terms of the geometric progression can be calculated this way, because now the quotient is equal to 1, so we cannot use the formula above, because it only valid for cases where q is not 1. So we use this one. So S5 is equal to 5 times A1, which is 5 times 5, is equal to 25. So this is the answer if we assume that q is equal to 1. Now what happens if we use the second? So this is done. Now we have to deal with this one. So the second part is if q is equal to 4, then we get another solution. let's check first what is d then. We know from this equation that 5 times q is equal to 5 plus 3d. So let's write this. 5 times q is equal to 5 plus 3d. 5 times q is 20, a is equal to 5 plus 3d. 15 is 3d, and then d is equal to 5. So then how we'll look the two series, the two progressions. So the A progression looks like this. The first term is 5, and then we multiply 5 by 4, because this is the quotient, it is 20, and then we multiplied by 4 is 80, multiplied by 4 is 320, etc., etc. So this will be the geometric progression. And then the arithmetic progression will follow this same. Similarly, the first term is 5, and the second term is we get that we add 5 to the first term. So 5 plus 5 is 10, plus 5 is 15, plus 5 is 20, plus 5 is 25, plus 5 is 30, etc., etc. So if this is the solution, what is, first of all, the fifth term of the arithmetic progression? So let's see. Which color did I use? Oh yeah, okay. So B5, the fifth term of the arithmetic progression, can be computed this way. Is 5 plus 5 minus 1 times the difference, which is also 5. So 5 plus 4 times 5 is equal to 25. So the first term, the fifth term of the arithmetic progression will be 25. And what will be the sum of the first 5 terms of the geometric progression? Similarly, we will use the now we can use this formula, because q is not equal to 1. So S5 is equal to the first term, which is 5, times q, which is 4, to power n, which is now 5, minus 1 over 4 minus 1. So we use the calculator here. Where is my calculator? Yes. 4 to power 5, 4 to power 5 is equal to 1024, minus 1 is equal to 1023 over 3, 341, times 5 is equal to 1705. So if we assume, in this case, if q is equal to 4, then these are the solutions. 25 is the fifth term in the arithmetic progression, and 1705 is the sum of the first 5 terms of the geometric progression. And then we are done with this exercise.